Right. What we were discussing is about the electricity, and also here we have some other part to discuss. The magnet part we have already finished. Under the electricity part, page number 110, let's go to the book. And we have done a few simulations, and I have given some exercises also. I don't know whether you have tried, but I explain this again in Steam class also. Try to do this anyway. Okay, let's go to the lesson number 8 very quickly, and this is about, okay, here. Okay, this one. Right, sound and hearing, no. Moving down, it is light. After the magnet part, yes, generating electricity. Okay, mainly we have discussed basic concepts of electricity like voltage and what is voltage and what is then we have discussed about after discussing about voltage, we have discussed about ampere and how to use a bulb, switches, how can we connect. So these things we have learned, and parallel connection, serial connection, we have learned something about that. Okay, then actually ways of generating electricity, that also we have discussed. So one thing is kinetic energy. A dynamo can be rotated either using kinetic energy or using water or using wind or using tidal waves, right? All these are possibilities. අපිට ඩයිනමෝ එකක් කරකවන්න පුළුවන් tidal wave නැත්නම් මුහුදු රළ පාවිච්චි කරලා. එහෙම නැත්නම් සාමාන්‍ය බයිසිකල් එකක් පැඩල් කරලා ඒකෙන් එන kinetic චාලක ශක්තිය. එහෙමත් නැත්නම් අපිට පුළුවන් වතුරෙන් කරකවන්න. ඒක තමයි ගොඩක් වෙලාවට මේ ජල විදුලි බලාගාර වල වෙන්නේ. ගොඩක් වෙලාවට මෙතන ජල විදුලි බලාගාර වල වෙන්නේ ඒක. ඊළඟට හුමාලෙන් විදුලිය ගෙනිද්දී හුමාලයෙන් මේක කරකවනවා. So that is basically steam power, hydropower, and also another thing is wind power. Wind power is also working with this kinetic energy concept. Wind power එක වැඩ කරන්නේ so kinetic energy. ඊට පස්සේ අපිට තියෙනවා the next thing is solar, that is directly using sunlight, that is converted. And dry cells and other cells are converted using, that is chemical energy. Chemical energy is converted to electrical energy. රසායනික ශක්තිය. මෙතනදී බයිසිකලේ තියෙන චාලක ශක්තිය. මෙතන සූර්ය ශක්තිය. ඔක පාවිච්චි කරලා අපි එනර්ජි හදා ගන්නවා. And this is a simple cell, and using lime fruit we have to use, one is galvanized nail, the other side copper. Why galvanized nail? Galvanized nail has a zinc, basically zinc plate. That's why we are using galvanized nail. ඇණයක් ගන්නකොට අර galvanize කරපු ඇණයක් ගන්න නිකම්ම යකඩ ඇණයක් නැතුව. එතකොට ඒකේ zinc තියෙනවා. zinc ආලේපනය කරලා තියෙන හින්දා ඒක පාවිච්චි කරන්න පුළුවන්. A musical birthday card. Why? Because it uses very small energy. We have discussed the same lesson in STEAM. I think Chaniru can remember, but others who were not there in the STEAM class doesn't matter. But still we need to discuss. We will discuss, right? Okay. එතකොට මේ සාමාන්‍යයෙන් මේකට බල්බ් එකක් වගේ දැම්මම බල්බ් එකේ එළිය පේන්නේ නැහැ. ඉතින් ගොඩාක් පොඩි කරන්ට් එකක් එන්නේ ලයින් බැටරි එකෙන්. ඉතින් ඒ හින්දා කරන්න ඕන එක්ක ලයින් බැටරි කීපයක් දා ගන්න ඕන. එහෙම නැත්නම් අපි කරන්න ඕන මේ ලයින් කීපයක් ලයින් බැටරි කීපයක් කනෙක්ට් කර ගන්න ඕන. එහෙම නැත්නම් ලේසි අර මේ මියුසිකල් බර්ත්ඩේ කාඩ් එකක්. ඔය තියෙන බර්ත්ඩේ කාඩ් ඔය අරිනකොට මියුසික් එකක් ප්ලේ වෙන්නේ හැපි බර්ත්ඩේ කියලා. ඉස්සර නම් තිබ්බ දැනුත් තියෙනවා. But it's not so common. We can use that. මොකද ඒකේ අඩු කරන්ට් එකක් use වෙන. It uses very small current, that speaker. Therefore you can use that speaker to that speaker because it will work with very small current. ඉතාලම අඩු කරන්ට් එකක් එක්ක ඒක වැඩ කරන හින්දා ඒක ගන්න පුළුවන්. Okay, then here fix 2 sheets of copper and zinc. මෙතන sheet දෙකක් තියෙන. හැබැයි වාට එහෙම නැතුව කෙලින්ම තඹ තහඩු කෑල්ලක් එක්ක මේ පැත්තට galvanized ඇණයක් ගන්න පුළුවන්. galvanized ඇණේ zinc ගාලා තියෙනවා. Then remove the circuit in the birthday card carefully, then the remove battery from it. Next, connect the copper sheet, the plate to the positive terminal of the zinc and zinc sheet to the negative terminal of the battery. මේකේ battery එක අයින් කරලා ඒ battery එක දාන තැනට මේකේ ධන ඍණ සම්බන්ධ කරන්න ඕන, and you have to record your observations. And here you can see the galvanometer. This is called center zero galvanometer. Why it is called center zero galvanometer? Because it can measure current goes which go to the both side, right? Current which is basically there, that both side we can measure using, that means the direction of the current can be different, positive to negative, negative to positive. Sometimes you can change the terminals. Okay, what will happen if terminal is changed? If it is like a filament bulb, it will work. If it is like a motor, it will change the rotation direction of the rotation, right? So those things will happen. But the thing is, if you try to use LED bulb, it will work only one side because it has a positive negativeness. And some of these positive negative things, like it's there, like then it will only work in that direction. But here in a galvanometer, you can measure either positive current or the negative current. When there is a positive current, it will go one direction. When there's a negative current, it will go another direction. That's why we are using center zero galvanometer here. I will show this once I back to Sri Lanka. Still out of the country, so I will not be able to show it now because I'm doing these classes being some different places, and I cannot carry all this equipment to those places, right? That's the problem. Okay, the next thing is, okay, the next thing is here you can see how electricity generated how electricity is generated using coil and a magnet. So this is also important part. So, but here when you're doing the practical, I have done this using different copper wires, right? I have done using different wires, but actually you have to get there are different, like here insulating copper wire 3 meter of wind in wire and bar magnet and a galvanometer. You just want to, okay, if you want to see the current which passes through, right, passes through the galvanometer. This is very small current, so we can use a galvanometer or milliammeter, either milliammeter. That also it's possible to use milliammeter, or like if you want to measure the voltage, we can use a voltmeter. That is also measuring in the millivolts and all. So that is also possible. But actually speaking, this copper wire need to be very thin, because if you use a thick copper wire, you will not be able to see this observation very well. Okay, let's see this practical, but they have not mentioned wind the insulated copper wire while around the cardboard PVC tube, diameter of 3 centimeter. Stretch well and clean two ends of the copper wire. Why? Because copper wire is basically, there is an enamel. This enamel is insulating the copper wire. That's why the copper wire will look it looks like laminated. The reason is the enamel. So you have to like stretch. You have to stretch both ends, because otherwise it will not conduct the current well. But here, no need to stretch, right? If you stretch, what will happen? It will not work, because the insulation is needed here. But both ends need to be stretched. Okay, let's see this in a video, because, the instructables, because they have not mentioned the gauge of this copper wire. So it's very important to get the copper wire in the specific gauge, because sometimes I said that thick copper wires, you will not be able to see this properly. So you have to use a very thin one. Let's see the gauge and all these things in instructable. So let me share the tutorial, because this one is not so clear. It has summarized the things. Let's go for a detailed one, right?
Excuse me, sir, I didn't hear you properly. Just tell me back, what did you say last?
I said I will show this using instructables. Isn't it? Hello? I hope you can hear me, right?
Yes, I can hear you.
Okay. Okay, because the in this, like, all these instructions are given, but the in the book it is not so clear. That's why I'm showing this, and I will give you this document also. Oh, I need to sign in. Sorry. Let's see this. Let's see this. Then you can understand, right? Here, so no need to read all these things and just right. Basically, if it's better if you can use a neodymium magnet, right? So neodymium magnets are so powerful. You can use a neodymium magnet because it's basically having very good power. But the thing is, but you don't want it to be larger, few centimeter, otherwise represent in real hazard. To get 3 volt, we must use a coil with a large number of windings. Uh, that's why I said, like, if you want to light up a 3 volt bulb, normally bulbs like this filament bulb take 3 volt. ඒ 3 volt bulb එක නම් මේකේ line මේ winding එක ගොඩාක් ලොකු winding එකක් ඕන with 300 windings and get the magnet in and out from the coil 10 meter per second, right? 10 ms, 10 milliseconds, like very fast, right? 300 winding එකක් තියෙන්නත් ඕන 10 milliseconds ඇතුලේ මේකේ in and out ගන්නත් ඕන, right? එහෙම කරොත් තමයි 3 volt ගන්න පුළුවන්. එතකොට ඒක ලේසි නැහැ. එතකොට 1 ටෙස්ලා මැග්නට් එකකුත් ඕන. 1 ටෙස්ලා මැග්නට් කියන්නේ සාමාන්‍යයෙන් සෙන්ටිමීටර් දෙකක් විතර තියෙන මැග්නට් එකක්. හැබැයි ඒක නියෝඩියම් මැග්නට් එකක් ගත්තොත්. අපි ඔය ගන්න ඔය චූටි මේ මොනවාද මේ ඔය ගන්න බා මැග්නට් තියෙනවනේ ලංකාවේ කඩවල විකුණන්න තියෙන්නේ. ඒ බා මැග්නට් නියෝඩියම් නෙමෙයි. හරිද? ඉතින් ඒ බා මැග්නට් එකෙන් බල්බ් එකක් පත්තු කරන්න බෑ. ඔයාලා කොච්චර try කරගෙන ඔයාලට එහෙනම් ලොකු වයින්ඩින් එකක් එක්ක ස්පීඩ් එකක් ගොඩක් වේගෙන් ඉස්සරහට පස්සට ගන්න වෙනවා. මොකද මේ කරන්ට් එක මේකෙදි වෙන්නේ ඇත්තටම here there is a policy, right? What's happening here? when සාමාන්‍යයෙන් අපේ තියෙනවා මෙන්න මෙහෙම රූල් එකක්. ධාරාවක් ගෙන යන සන්නායකයක් වටා නැත්නම් if there is a conducting wire there will be electromagnetic field. හරිද? එතකොට වයර් එකකින් මේ කරන්ට් එක යද්දී ඉලෙක්ට්‍රෝමැග්නටික් ෆීල්ඩ් එකක් කියන්නේ විද්‍යුත් චුම්බකත්වයක් ඇති වෙනවා. එතකොට චුම්බකයක් වයර් එකක් කරා ගෙන යද්දී ඔකේ අනිත් පැත්ත විද්‍යුතේ හට ගන්නවා. Okay, understood? Okay, so that is the reverse of that. When magnet is moving through, like moving in and out to this wire coil, there will be current, electricity. Right? That is what used by this dynamo. Dynamo එක use කරන්නේ ඒක dynamo එකේ තියෙන්නේ ඔය coil එකක්. ඔය coil එකේ magnet එකක් තියෙනවා. නැත්නම් permanent magnet එකකුත් තියෙනවා. නැත්නම් electromagnet එකක් use කරන්න පුළුවන්. but permanent magnet එක ලේසි. ඒක කැරකෙනකොට ඒක coil එක හරහා cross වෙලා යනකොට මේ magnetic field එක මේ හින්දා electricity එකක් විද්‍යුතයක් හට ගන්නවා. ඒතර මේ dynamo එක වේගෙන් කැරකෙද්දි current එකක් එනවා. ඕක වෙන්නේ ওই විදිහට. Right? Okay, that's what we are going to test now. එක තමයි අපි test කරන්නේ. Here මෙයාලා මේ දීලා තියෙන මේ measurements හරි, right? So that's why I said that the measurements given in the book sometimes you won't be able to see proper result. So you try with this. Okay, 1 meter PVC tube, 16 millimeter diameter, right? So you have to take 1 meter PVC tube. මීටරයක් දිග PVC tube එකක්. ඊට පස්සේ here he has like even explained the amount he paid, and here 12 into 20 millimeter cylindrical neodymium magnet. The මේ magnet එක මං හිතන්නේ ලංකාවේ හොයාගන්න අමාරු ඒ ටිකක්. But still you can order from AliExpress or Daras එකේ තිබ්බ වගේ දැක්කා. Let's see. No. Neodymium. You can see neodymium magnets are there, but cylindrical එකක් ගන්නත් බෑ මේක නිකන් මේව එක අරගෙනත් බෑ. This is quite expensive. Here you can see the bar magnet also, right? This is 20 by 3 millimeter. අපිට ගන්න කියලා තිබ්බේ කීයද? 10 magnets of 12 2 millimeter. එහෙමනම් මේවා 10ක් ගන්නවා. 12 2 millimeter ඒවා 10ක්. 12 2 millimeter කියන්නේ මේවනේ මේක 23 millimeter. මේ වගේම පහක්වත් ගන්නවා. That's why I said, but you need a powerful magnet. Powerful magnet, then you can do this, right? Anyway, you can get this cylindrical magnet. These neodymium magnets are there in Daras, but little expensive, right? Little expensive than normal magnets. NS ගහලා තියලා පාට කරන magnet තියෙන. ඒවා නිකම්ම නිකන් අර වාණේ වලින් මේක නියෝඩික් හදලා magnetize කරපේවා තියෙන. ඉච්චර හොඳ magnet නෙවෙයි ඒක. mixture එකකුත් තියෙනවා නිකන් mixture එකක් තියෙන එකකුත් තියෙනවා ඒකේ. But these are not very good magnets. But this neodymium, I explain about different magnets, right? I hope you can remember in the magnet lesson, we have explained about different magnets. So neodymium is one of the powerful thing. And you can see how they are doing this and how the coil is wrapped around. You can see very thin wire need to be taken, thick wire kakaragana bear. It's very thin wire. What is the gauge? Here, 0.2 millimeter enameled magnet wire. Right? 0.2 millimeter enameled magnet wire. That's what they have taken. Right? Okay, just wait. Okay. So that's why you have to take thin wire and do this, right? I explained just. Okay, let's going back to our book. Going back to our book. Okay, this is the person, right? An electric current is generated by moving magnet inside a coil of wire. That is basically founded by a person called Michael Faraday, right? He was the one to discover this. This is called Faraday's law, right? Faraday's law. Faraday's law is basically about this moving magnet generating current, right? So this part is there in PHET also. PHET, Faraday's law in PHET. Let's see here. You can see in PHET simulations how Faraday's law is working. Just press this. And you can see PHET interactive simulations. Okay. So this is, I'll send you the simulation link. You can also do this with me. Here's the link. Please do this with me now. Okay, I'm moving this magnet. You can see the north-south particles. I'm just moving this magnet. If you move faster, more amount is generated. But actually speaking, in order to generate this, right, in order to generate this kind of current, you need a powerful magnet as well as number of wrappings in the coil should be very high and the thin coil is needed. Right, let's say voltmeter. And you can see when I'm moving in, it is minus. When moving out, it is plus. Moving in, minus. Moving out, plus. That is why the current is two directional. It's bidirectional. Right? It's bidirectional. So voltage which is generated by a dynamo is a bidirectional. It is not a DC voltage. It is AC voltage. Right? AC. AC means what is AC and DC? Yes, anybody? Can you tell me what is AC voltage? What is AC voltage? What is DC voltage? Hello, guys. I'm asking from you. What is AC? What is DC? Yes, please reply in the chat, or you can use microphone.
The DC voltage is what produces electricity from straight away as direct, and AC is not like that.
Yeah, DC is direct current. That I agree. DC is direct current. So what is then AC? Yes. What is AC? DC is direct current. Yes. AC.
Alternating current?
Alternative current. Yeah. What is alternative? Alternative means it's bidirectional, right? Alternative.
Yeah.
Alternative. Alternator is also there in vehicles. Alternative. Right?
So excuse me, can you send me the link because I didn't get that.
Is PHET one or the instructable one?
What are your PET?
PHET. Okay. This is the PHET one. And if you need the instructable one related to the experiment, this is it, right? This instructable one is very clear, right? Very clear, precious, and you will get exact results. So that is the advantage. Okay. Now this, you can see the voltage when I move this one side, one minus, plus, minus, plus, minus. This is how, like, so when motor rotates, right? So assume that this magnet is rotating. Right? When motor rotates, it generates current like this. It is accumulated current. So if there's a filament bulb, that is okay. But if there's a LED, it will turn on and turn off. Because LED is, you know the reason. LED will work. LED will work only when one side, the LED is basically supporting DC current. So if it is connected to AC current, LED will turn on when plus minus are correct. When plus minus are wrong, it will off. Therefore, if this motor, if this dynamo continue to rotate, LED will blink like this bulb. Not blink like not blink like this bulb. It will only blink this direction, maybe or this direction. But you can see this filament bulb is basically blink in both directions. Okay, filament bulb is you can compare this right here. When the coil is small current, but coil is big current. That's the thing. Okay. And the field lines will give you like how the when this field process it generate, right? Will the wire field process it generate the current. Okay, then we have clear idea about what's happening there in the electricity and about the Faraday's law, what Faraday has said. And this is you can see this is small hydropower station. Okay, this practical you can do at home. You can see some yogurt spoons, yes, and a cork and a galvanometer. Galvanometer is harder to find at home, so you can use maybe that speaker, right? The birthday card speaker, because it consumes very less power. The birthday card speaker can be used because it consumes very less power instead of the galvanometer. Empty pen tube and small bulb. So here empty pen tube is connected to the gallon, like this electric motor. You can use 12-volt motor maybe. Then the pen, why you are taking the pen tube or pan but ගත්තම ඒක ගානට ඔය මෝටරේ තුඩට ප්ලග් කරන්න පුළුවන්. ඊට පස්සේ ඒක යන්නේ ඒක දික් කර ගන්න ඕන. නැත්නම් මේ මෝටරේට වතුර යනවනේ. ඒක දික් කරගෙන ඊට පස්සේ කිරලෑම්බේ ගහලා cork is in plug, and after that just give me 1 minute. Okay, then why this pen tube is needed, we have discussed. The pen tube can be connected, extended, like can be connected and extended this from the motor. Then we can place this somewhere else, right? Then yogurt spoons, you have to put it in one direction and then you have to drop water. And actually this setup can be used in few ways, either to steam ජල වාෂ්ප වලින් හුමාලයෙන් මේ යෝග ස්පූන් එක කරකවන්න පුළුවන් හුමාලයටත් හුමාලය පිට වෙද්දී අර ඔගොල්ලෝ දැකලා ඇති මේ වගේ මොනවාද අපි තියෙන්නේ පෝච්චිය හුමාලය ඒකෙන් ඒකේ කට හරියට ඇල්ලුවම අත පුච්ච ගන්න නැතුව මේක කරකැවෙන. ඒක එකක් අනිත් එක වතුරෙන් හුලඟෙන් නම් මේක චුට්ටක් අමාරුයි. ඒක කටින් පිමින්න පුළුවන්. ඕන නැත්නම් අර මේව එකක් වගේ තමයි අල්ලන්න වෙන්නේ. blower එකක් වගේ. blower එකක් වගේ අල්ලලත් පුළුවන්. Okay, that is it. Right. Okay, then right here you can see in Sri Lanka what are the power stations available. These are hydropower stations. Kotmale, Lakshapana, Victoria, Rantave, Randanigal. And wind power station is there in Hambantota and Puttala. And even in Norelia, I have seen. Norachole, which always breaking is coal power. Coal power is basically again engine. Again, the rotation is done using engine. Then fuel power. There is also Kalanithista. That is another one. So these are basically, you can see in all, fix a dynamo, large turbine, rotate the turbine, rotate the turbine, rotate the turbine, rotate the turbine. All are using kinetic energy, but no solar stations. Right? No solar stations. That's the thing. Like we need to think about that also. Implement solar stations because that is what lacking of. We learned few ways of generating, and batteries, of course, chemical reactions are of course expensive, and also there's another one that is atomic reactions. Right? Atomic, basically, you know, in sun, solar energy is generated using these atomic breakdowns. Right? So we can use that. You know, these we can call atomic energy. Atomic energy is kind of dangerous because it needs to be well controlled. Otherwise, the radiations can even kill the people. Therefore, it needs to be well controlled. But that is also a powerful way of generating energy. Okay. Then to the simple cell. Okay, let's do the simple cell practically. Then we will understand how simple cell generate current. But again, if you use copper and zinc and also dilute sulfuric acid, you can create the this simple cell. But the problem is it will not be enough to turn on a bulb. ඒකටත් අර ස්පීකර් එක තමයි මට රෙකමන්ඩ් කරන්න පුළුවන්. මොකද බල්බ් එකකට මේ සිම්පල් සෙල් එක ඇත්තටම මේ මදි කරන්ට් එක. මේකෙන් එන එක. අපි හදලා බලමු. But the thing is, I think it will be very, very small current mostly. Okay, let's do that. I will do that using we have few things to discuss in this lesson, but for today let's finish the simple cell. Actually, I'm not that well to do that last, that's why I was hurrying in finishing this. But anyway, I'll do the simple cell part and quickly finish this, right? Because we have enough time to finish the lesson. We have done more than expected. You can do the simple cell with me, but the thing is, most probably you don't have this software installed in your computer. This software is crocodile chemistry.
Excuse me, sir.
Yes.
I tried to install that app before today, but it is just giving an app called Good Download Manager.
Oh.
Something
I
like
think
that.
you have. I have sent this previously, right? This app. Okay.
Yes.
What I can do is, I think I have crocodile chemistry in my computer. I will. what I can do is I will share this in Google Drive as a link, right? As I remember, I had this set up, but not sure whether it's there in this machine. This is my temporary computer. Let me search. Yes, I have the software with me. What I can do is I will share it to you using Google Drive, right? To your WhatsApp group, I will share. Then you can download and install. And there is a key. You have to put that key, right? After installing, there is a key here. This key you have to. Where's the key? Here. This key you have to put in it after that, because it's this is bit old software. Now you will not be able to find this because now this is owned by some other company, right? But anyway, let me demonstrate that first, how this is working. I'm going to take from the part library. First, I need some chemicals. Actually, I will go to equipment and electrochemistry. Under electrochemistry, I will get the electrodes. I need, what are the materials used in your book? Copper and zinc? Is it copper and zinc?
Yes, sir. Yes, sir.
Okay. Copper is plus, right? Zinc is minus, I guess. Okay, I will take copper and zinc, and again, let me show this using just one copper, zinc, and sulfuric. Sulfuric acid you can buy from a shop. That is called battery acid. In hardware you can buy this battery acid. Is not that expensive, right? Less than 1,000 rupees you can buy it from hardware. It's battery acid. That is dilute sulfuric, but don't try to find sulfuric acid, because sulfuric acid is so dangerous, because sulfuric burn can even kill. Therefore, don't try to use sulfuric acid, because you can find sulfuric acid from chemical labs, but it is very dangerous. See what will happen if sulfuric burn is there. Here it is not sulfur burn, sorry, sulfuric burn. So, sulfuric burn can happen because of the acid rain also, but this is not up to this. Acid rain is basically sulfur in the in air layer is basically mixed with rain and creating the acidic, but that is not that much acid. But here, see this is very dangerous. Can you see? It's very difficult to look at even, because sulfuric is a powerful acid, right? Normally we used to say in your childhood, if acid it is sour taste, and if it is base it is bitter taste. But this sulfuric don't taste. You will not find your tongue after that. That is the thing. The sulfuric is a strong acid. That you can do for the acetic acid, vinegar and maybe lemon. You can taste and see with the acidic or not, but not for sulfuric, because it's a very strong acid. And that's why you have to take dilute sulfuric. Dilute sulfuric is sulfuric which is mixed with water. It is not that strong. Concentration is very low. Concentration is very low. It's dilute. It's basically picking a single name, Tanuka sulfuric. Okay, let's use glassware, and I'm going to use a standard beaker of 100 milliliter, and let's put these electrodes, zinc one side, the other side copper. Okay, and then I need sulfuric acid also. From the chemicals I will get acids, and this is sulfuric acid, but you can see it is one name. One name means the concentration is very high. If you use one name, but battery acid is not that maybe you can use 0.1 name, right? I'm changing it to 0.1 name, sulfuric. Now you have this sulfuric acid. And after that, I will use, I think electrochemistry part I have in the equipment, electrochemistry. Yes, I have a voltmeter. So let's use voltmeter and measure the current going through this, right? Let's use voltmeter. Oh, this is actually positive. Need to connect this to this edge. This is negative. Negative zinc, right? Okay, let's put sulfuric acid and see. This is 0.1 name. It's not concentrated, it's dilute. Let's put this, and okay, you can see it is only 1.1 oh, I have to change the edges. It is 1.06 volts, very small. 1.06 is very, very small voltage. Now let's use voltmeter again. Oh, now it's even dropped. Millivolt. Because it's dropping, right? When reaction is there, it's dropping, dropping. So this current is not enough to turn on a bulb. Right? At least you have to combine two cells together. How to do this? I will remove this again. No, I don't need. Okay, let's delete it. I will get these electrodes. Before that, I need the beakers. Glass beaker, this beaker, and this beaker. Two beakers. Yes. Then I need electrodes. Electrodes. Where I saw the electrodes? Equipment. Is it? Yeah. Then copper electrode. Zinc electrode. Again copper electrode. This is how connect multiple cells. Again zinc electrode. Now the voltmeter. Just connecting like this. We need to connect these two also. Okay. Okay. Now let's put sulfuric and see the voltage. Sulfuric to this and sulfuric to this. You can see it generate closer to 2 volt, right? Let's increase the concentration, but concentration you cannot increase because you are buying this from shops. You will not be able to increase. So let's increase this and put this. I have to make the vessel empty, I guess. Yes, I have to make the vessel empty. Vessel actions, empty vessel. Okay, here vessel actions, same thing. Just click on the vessel. Okay, vessel here. Okay, vessel actions, empty the vessel. Now put in 0. This is too little concentrated, and you can see now the voltage is little higher than the previous one. And already reaction, half of the reaction happened. That's why. Otherwise, if you put 0.2, you will see higher rate. But anyway, now this is enough to marginally turn on a bulb. This is enough to marginally turn on a bulb. Okay, that's it. So you can create this cell. I suggest you to do this at home, and please send me some photos and videos to our WhatsApp group, because this simple cell you need to create and get the experience. How can you find copper? Copper sheets are available in the market. In a shop, in a hardware, you can buy. Zinc sheets are also available. But if zinc sheets are not there, you can just find zinc in dry cells. This chemical dry cells, you can find zinc. How? Just go there. If you take a dry cell inside, and you will see this zinc layer. So let's put zinc also, because a dry cell inside, you can see zinc like this. When you remove the dry cell, the basic cover, inside that you can see this is aluminium basic cover. When you remove that, you can see this glass like it's not this metal like thing. This is zinc, right? This is zinc. This is negative zinc. This zinc you can see. After removing this, you will see the zinc. That also you can use. Either that or you can buy zinc from a shop. Okay, that is how you have to create this first simple cell. And remaining part I will discuss next week, right? Because I said that I'm not in a position to do the class today. But anyway, thank you very much for joining. Let's do the class next week. Okay, good night.